Further, for the formula of intensity, if the phase difference, try to understand, it is the phase difference at any point from two sources is phi. So say for example there are two sources and this is the point in the medium where the two waves which are reaching here, okay, two waves are reaching here, and the phase difference between these two waves is phi, and for that we shall find a general formula for intensity. Okay, it is phase difference that we have to keep in mind. We consider any arbitrary point G which is shown in this figure, okay, that is in the medium. So this point is the point which is considered here, and that point is G point, okay, and we are considering that, or we want to find out the formula for intensity. Let us consider that the phase difference between the two displacements is phi. Okay, so the displacement produced by first we consider as y1, and if y1 is taken as a cos omega t, then the displacement which is produced by the second wave which is reaching here at this point G, we consider two waves, okay, as I have explained that this is the point where two waves are reaching, okay, then the first wave is coming like this, second wave is coming like this, and the phase difference between these two waves is phi. So we consider the first wave as y1 is equal to a cos omega t plus phi. Then the second wave which is reaching here is having the phase difference, or rather its wave equation, we can say, not the phase difference but the wave equation, that is y2 is equal to a cos omega t plus phi. Okay, so these are the two wave equations. Okay, now the resultant displacement according to the superposition principle can be written as, can be given by y is equal to y1 plus y2, okay, and it can be a cos omega t plus a cos omega t plus phi. Now we say that cos A cos B, if this is the format cos A plus cos B, then you can write 2 cos A plus B by 2 cos A minus B by 2, similar formula we are applying here. We are taking A common from this, okay, so we have cos omega t plus cos omega t plus phi, and if we apply this rule then it becomes 2a cos phi by 2 into cos omega t plus phi by 2. Now here if you consider this equation, then the resultant displacement is given by this particular formula. Here this 2a cos phi by 2 can be considered to be the amplitude of resultant wave, and as you know that intensity is directly proportional to the square of amplitude. Okay, so intensity of this superposed wave will be I, which is proportional to square of that 2a cos phi by 2, and that will be 4a square cos square phi by 2. Okay, now here initial intensity, if you take say I0, that of the superposing wave as I0, then it is proportional to the square of amplitude, and amplitude of this superposing wave is A, so I0 proportional to A square. Okay, and now the intensity which we got is nothing but 4A square cos square phi by 2. So if you take the ratio, then I upon I0 if you take, then this A square will be cancelled out and you will have 4 I0 cos square phi by 2. Okay, it can be easily understood. Okay, the intensity of the new wave, okay, rather the intensity if you want to find I upon I0, okay, I upon I0 if you want to take, then it will become 4 a square cos square phi by 2 divided by a square, and a square will be cancelled out. So it becomes I upon I0 to be 4 cos square phi by 2. So I is equal to 4 I0 cos square phi by 2. This can be written in this particular way. I is equal to 4 I0 cos square phi by 2. If this equation is obeyed, then the constructive interference will form at a point G an interference leading to maximum intensity. Okay, if this equation is to be considered, that for the intensity which is produced at this superposing point, that is G point or point G. Okay, for maximum intensity, from this equation we can say if phi is equal to, this equation you can understand from trigonometry. If you want to take cos square phi by 2 to be 1, then this phi must be 0, 2 pi, 4 pi. Okay, for such values of phi, there will be a constructive interference. And if the intensity is to be made minimum, that is 0, then this must be phi by 2 must be equal to pi by 2, because cos pi by 2 is 0. So the value of phi for making it 0 must be plus or minus pi, 3 pi, 5 pi, this way. So that will lead to the 0 intensity, and point G will become dark, or there will be a minimum intensity and there will be a destructive interference. Okay, so this is the condition that for phase difference of 0 plus or minus 2 pi plus or minus 4 pi, there will be a maximum intensity and there will be a constructive interference. And for the values of phi, that is if phi is plus or minus pi, 3 pi, 5 pi, then there will be a 0 intensity and that will lead to the destructive interference. Okay. Now there is an explanation of the intensity of the point of superposition of the waves emerging from it by explaining the coherent and incoherent sources. Now if light sources have constant initial phase difference, or their phase difference does not change with time, then they are called the coherent sources. This I have told you earlier in the other video also, that there must be a constant phase difference between the waves which are emerging from different sources. Okay, or we can say their phase is same, then also the sources are said to be coherent sources. In the interference pattern, intensity at any point does not change with time. That is the main thing. Whenever you have interference pattern, the intensity will not change with time. This type of interference is stationary interference. There should be two coherent sources for stationary interference, and the amplitude should also be the same. This is the required condition. Try to understand. There must be minimum, there must be minimum two stationary, or rather two sources. And the amplitude should also be the same. There should be two coherent sources for stationary interference, and amplitude should also be the same. The position of the maximum and minimum in the stationary interference will not change with time, or we can say wherever there is a maximum intensity will remain maximum if the phase difference is same, provided amplitude is same. That is main condition. When the phase difference between the two vibrating sources changes very rapidly over time, then this source is known as incoherent source. If the phase difference changes or phase changes that of one source with respect to other very rapidly, then these sources are said to be incoherent sources. The light intensities are added into each other due to superposition of the waves emerging from incoherently sources, and two different light sources illuminate the wall. Try to understand, two bulbs are there in the room, okay, and if these two bulbs are on, okay, then they are considered to be incoherent sources, and resultant intensity is just the sum of their intensities, or we can say we do not have the interference produced by these two bulbs which are on in the room. When the path difference of the two sources is not constant, the interference pattern also changes with time. There must be a constant path difference also. So there must be constant phase difference and the path difference. If the path difference changes very rapidly with time, the position of maximum and minimum will also change rapidly with time, and we will see the average distribution of intensity with time. So that example which I have given, two bulbs which are on in the room, will give the average distribution of intensity with time, and this average distribution of intensity, as we have written that this value we have already derived, I is equal to 4I0 cos square 5 by 2. Now you want to take average, then average has to be taken that of this function cos square 5 by 2, and this, as I have explained, symbol represent the time average term, or we take the average over a time period. If phase is a function of time, try to understand, phase is a function of time means phase changes with time randomly, okay. The time average quantity cos square 5 by 2 will be 1 by 2. The average of this cos square 5 by 2 will be equal to 1 by 2, as you know that if you take the average of cos square theta over an entire period, then that average will be 1 by 2, and the resulting intensity at all point, because as you know that average of this cos square 5 by 2 is 1 by 2, then what will happen, 4I0 into 1 by 2 will give you the average intensity as 2I0 at all points, okay. Now there is Young's experiment. Explain the Young's experiment, arrangement and experiment to produce the interference pattern. Now see, this British physicist Thomas Young made a ingenious technique to obtain the coherent sources. How he has produced the coherent sources? By the divisional or rather division of wavefront, and demonstrated the stationary interference. So this is the scientist who produced the coherent sources. First of all, how to produce coherent sources, that was the question. He produced the coherent sources by the division of wavefront. This experimental arrangement of the Young's experiment is shown in this figure, you can see, okay. Here S is a small hole. Try to understand, this S is a small hole on the sheet, we can say. So we can say S is the small hole on the sheet A, we can say. On screen we cannot say, it is a just a sheet, okay. S1 and S2 are the two pinholes, okay. Two holes are there parallel to the screen A. So here there are two other pinholes, okay, which are shown in this figure, you can see, okay. S is the first hole, or we can say pinhole, okay, and from this we can say the light is incident, and there are two other pinholes S1 and S2. Now what will happen? The light will be incident from this and it will pass through this S1 and S2. Okay, so the wave front will be divided. Okay, the two pinholes are parallel to the sheet A. S1 and S2 are two pinholes on screen B, and the distance SS1 and SS2 is same. Try to understand. We can say that there is a, say, this kind of sheet is there. Okay, and you just make a slit in it. Okay, keep another sheet parallel to it, or we can say its plane is parallel. Then here there are two parallel, we can say, pinholes are there. Then what will happen? The light will reach to this simultaneously, or we can say this is your S, that is first slit or first hole, and this is S1, the second sheet which is having the slit. Okay, then this is S2 as the second slit on the sheet B. So what will happen? SS1 and SS2 will be same. So distance between the SS1 and SS2 is same. Now this waves which are coming, or rather coming out from S, will reach at S1 and S2 simultaneously. Okay, this screen, third screen C, is parallel to B, or their planes are parallel. Okay, this third screen is shown here, which is a screen on which the interference patterns are produced. Okay, and it is kept parallel to the second screen, and the distance between the B and C, this distance is capital D. Okay, now whole S is lit by a bright source. Light spread out from S and fall on both S1 and S2. Here distance S1, S2, or rather we can say the distance between this S and S1 and S and S2, they are same. So distance SS1 and SS2 are equal, so they behave like a coherent source. Because light waves coming out from S1 and S2 are derived from the same original source, because the source here is same. So source is same. Okay, and from this source we have now two different waves because of these two slits which are made on this second sheet B. Okay, so because light waves coming out from S1 and S2 are derived from the same original source, and any abrupt phase change in S will manifest in similar phase change. There will be a same phase change in the two waves which are coming out from this S1 and S2. So the phase difference will remain constant. The waves which are coming out from S1 and S2, the phase difference will remain constant, because whatever phase changes here, the manifestation of that change in phase will be same in both the waves which are emerging out from S1 and S2. Okay, so these sources S1 and S2 are behaving as a coherent sources, thus the two sources S1 and S2 will be locked in phase, we can say. Whatever there is a phase change in S, there will be a same phase difference between the waves which are coming out from S1 and S2, so they behave as a coherent sources. Now we have the formula of path difference at a point on the screen in Young's double slit experiment. Now here this double slit experiment is very clear, you can see, okay, how the arrangement was done. This is the source, okay, this is the source, this slit is a source. The waves are produced here and they are reaching at this S1, S2, okay, and the waves which are coming out from this S1 and S2 are getting superimposed, okay, and the particular interference pattern is produced here, okay. So these are the two sources. Now this point P is here on the screen, and this is the source S1 and this is the source S2, and the distance between this S1, S2 and the screen on which the interference pattern is produced is capital D. Okay, and the distance between these two sources, that is S1, S2, is D. Okay. So here if you consider its midpoint, then this must be D by 2 and this also will be D by 2. This can be understood from the figure, and we can say that the distance where the interference pattern is produced from point O, that is midpoint of this screen, this distance is x, okay. If you consider this much as D by 2, then this G2M will be x minus D by 2, okay. This can be understood easily, okay. This distance is taken as x, okay. This distance is taken as x, okay, and this will be x plus d by 2 if you consider it from here, from this point say n, okay. From point n if you consider, then that distance will be x plus d by 2, because x is the distance from point O, okay. From point O, this point to this point P, the distance is x, okay. So this is the figure or understanding of figure, okay. Here G prime is the screen, okay. So interference obtained at point P on the screen, or we can say we are interested about the interference which is produced at point P. So P is the point which is situated at distance x from the midpoint of the screen, or we can say OP. This distance O to P, okay, this distance O to P is x, okay. So this is very clear to you. Now S1M perpendicular to GG prime, S1M is perpendicular to GG prime, you can see, okay. Here this S1M is perpendicular to the screen, okay, and S1M is the distance which is nothing but distance of screen, which is denoted by capital D. So PM, as I have explained, is x minus d by 2. Here P to M, this distance is dx minus d by 2, and this distance of Gn will be x plus d by 2, or we can say Pn or Gn, okay. This point you consider P, then P to N, this distance will be x plus d by 2, okay. You can see it properly also. Here you can easily understand that this distance totally is x, then this distance must be x minus d by 2, as this much distance is d by 2 and this is also d by 2. So from this point N to this point P, the distance will be x plus d by 2. Okay, so this is very clear from the figure. Now from triangle PMS1, we have to take the triangle PMS1. Okay, so just consider the triangle that is PMS1. We can say S1P square is equal to Pm square plus S1M square according to Pythagoras theorem. So S1P square is equal to S1M square plus Pm square, and S1M is nothing but, okay, S1M is nothing but d. So it becomes capital D square, and this becomes x minus d by 2 the whole square. And if you take the triangle that is PNS2, if you take the triangle PNS2, okay, that I am showing it here, okay, PNS2, okay, this triangle I am trying to explain, PNS2, then PS2 square is equal to S2N square plus Pn square. Okay, that is very clear. Again, S2P square is equal to Pn square plus S2N square, and S2N is nothing but D. So D square plus x plus d by 2 the whole square it will be. Okay, so it is written here. Okay, now these are the two equations, that is for S1p and S2p. You can see S1p square, this is S1p square, this is S2p square. Now we take S2p square minus S1p square, okay, this minus this, okay, so you will get the left hand side subtracted, okay, that is written here, okay, d square plus x plus d the whole square minus, okay, d square, and this must be minus, okay, so minus x minus d the whole square. So we get x plus d by 2 the whole square minus x minus d by 2 the whole square, and if you just open the bracket and simplify, okay, then you are getting here as 2 times xd, because this x square will be cancelled out, this will be cancelled out. Here x and d are very small compared to capital D. Try to understand. This x, that is distance of the point from the midpoint of the screen, that is the distance where we are interested for the interference pattern, that is x, is very small. Small d is the distance between S1 and S2, that is slits which are made on the sheet B, very small in comparison to capital D. So S1p is equal to S2p, and that is equal to capital D. Okay, S1p and S2p will be equal to capital D. So here, instead of these two, we can write d plus d. So it becomes 2d, and it will go in the denominator of 2xd. So we can say that S2p minus S1p, okay, S2p minus S1p into bracket d plus d, here d plus d, okay, is equal to 2xd, and S2p minus S1p is equal to 2xd upon 2d. Okay, so S2p minus S1p, here we can cancel these two, okay, so it becomes xd upon capital D, and S2p minus S1p is the path difference, S1p to S2p. Try to understand. Here you can see the path difference from the figure, okay. S1p is small path and S2p is a larger path. So S2p minus S1p will give you the path difference. And that path difference is found to be xd by d, okay, xd by capital D. Okay, if this path difference, that is xd by d which we got, is n lambda, where n is 0, 1, 2, then intensity of light at this point P will be maximum, and that is producing constructive interference. Or we can say, in general, any distance xn from the midpoint d upon d is equal to n lambda, then there will be a constructive interference, n is 0, 1, 2 up to infinite. And for S2p minus S1p, the path difference, if that path difference is n plus 1 by 2 lambda, n plus 1 by 2 lambda, or we can say this path difference, that is x and d by d is equal to n plus 1 by 2 lambda. Okay, then xn is made as a subject of formula here. Xn is equal to n plus 1 by 2. Okay, lambda capital D upon small d. Then these are the points which are situated at these distances. At these distances will have destructive interference or minimum intensity of light, where n is 0, plus or minus 1, plus or minus 2. This is the condition. Okay, so for destructive interference, the path difference, or we can say the path difference obtained by us is n plus 1 by 2 lambda. Okay, we can say if you want to have a constructive interference, then there must be a path difference which is equal to n lambda, and for destructive interference, the path difference must be equal to n plus 1 by 2 lambda. Okay, the distance of bright fringes from the midpoint of central bright fringe is x, but minimum of 0th order cannot be obtained, or we can say 0th order minimum is not obtained. Hence the formula of destructive interference we can write as n minus 1 by 2, because 0th order bright fringe is not obtained. Okay, n minus 1 by 2 lambda, and the number will begin from plus or minus 1, plus or minus 2. Okay, because 0th order dark fringe, try to understand, 0th order bright fringe is obtained, but 0th order dark fringe is not obtained. Okay, so we write the formula as n minus 1 by 2 instead of this plus 1 by 2. Okay, try to understand this theory, repeat the theory 2-3 times. Okay, and understand the concept. Thank you very much.